All right. Okay, what we're going to do here next is make it so that we can actually render things nicely, because as you remember, this is what our texture looks like right now. It's upside down in the wrong place and also white and pink, which isn't ideal. First thing we're going to do is fix it so that the texture is black and white. Array chunks. This is unstable, so I'm going to have to deal with that. And then we're going to go flat map those chunks, those RGB chunks, into uh, well, if RGB is equal to, whoops, if it's magenta, basically, is the question here. Then we want to return black. Else we return the RGB values back we got. I think, well, because we need to do, okay. It's an unstable feature, but it's a good one. Get our array chunks. Thank you. Oops. Goes like that, doesn't it? There we go. And these need to be copied. And that needs to be equals. And we need to make this a vec. Oh, there we go. Ow. Mosquitoes. All right. Cool. So if we run it now, you can see that it's black and white. Excellent. All right. We don't want it to be black and white either, though. Of course, we want it to actually be colored. So we're going to need a shader. We're going to need some more uniforms, some different uniforms. So I'm actually going to go and where's the descripts thing? This I'm going to strip out and make it uniforms. I'm going to make a function, and I'm going to that's going to return that for now. Of course, we're going to change that. Okay, so what does our shader need? It needs to be able to position uh, the stuff that we're drawing. I'm going to call that pos offset for reasons. We need to be able to scale it as well, because we might want a different amount, different sized. It can change. We need a UV offset in order to position things in the texture, basically. I'm not going to use a UV scale here. I'm going to hard code that into the quad that we're using. I'm going to make the UV lengths be 1/16. That should save us something. We need a foreground color and we need a background color, and we're going to have a color. So that's a thing as well. So let's see. Let's do the color first. Standard pot stuffed. Okay, and our uniforms we're going to have to change now. So that's going to be os offset. It's a vec2. A position scale. It's also a vec2. UV offset is a vec2, and then foreground. It's a vec. It's a color actually, and a background. And make the corresponding changes here. Need a comma there. UV offset and foreground, float 4, and background, also a float 4. course, this is bad now. This is what we're actually going to be rendering it. This is going to be a loop eventually that just goes through the entire terminal thing. But let's do some definitions here first for how big we want this thing to be. Ow, mosquitoes, man. I'm gonna do a 80 by 25 terminal. I think 25 or 24 is standard. Can always change it later. Might be useful. All right. So let's just imagine that we have a character that we want to draw. It's going to be an @ sign, fittingly. Let's have it have an X. That's going to be at 10. And Y at 10 as well. These are I32s. We're going to have the foreground, let's make it red over blue. Red. Uh, and background's going to be. Why is. What do you mean you don't have a field name day? Oops. There we go. There we go. So what we have to figure out is we've got a position offset. We need to figure out that from the X and Y on the grid. We've got a position scale. We have a UV offset. And that's also going to have to be figured out from the... no, I'm going to make this 0.5 for now, because that is going to be useful. And foreground and background color, we already know that. So this is what we have. Let's add that to the shaders. So actually like this. Actually, we could just put it here. Okay, so in the vertex shader, we need loss offset, we need position scale, and we need the UV offset. And the way that's going to work is going to do it in position times the scale plus the offset. And this is just going to be plus the UV offset. And then in the fragment shader, we're going to need, I think it's uniform low P. Back 4. I think that's still valid. No, what did I forget? Mass. But is it really uniforms contained uniforms? That seems very silly. All right. Okay, so we're position offset here. This is because we don't have wrapping on the thing. But actually, well, no, let's not do that. That's fine. It's stretched is what it is. If we remove the UV offset, it won't be stretched anymore. Let's go ahead and change our vertex as well to be in terms of 16ths of a texture, because our texture has a grid of 16 by 16 characters, making up 255. So each cell needs to just be a 16th wide, basically. There we go. That's whatever character is in the middle. Notice that it is upside down and in a weird place. So let's figure out how to deal with that. It's going to be 10, right? Okay. So the X position of it. First of all, we need to get into, well, basically we're going from 0 to 80 to -1 to +1. So you can take the X as an F32. Can I divide by 80 term width as F32? I can. That's fine. Okay, so that gets us from 0 to 80 to uh, 0 to 1. If we subtract 0 0.5 from this, we are now in negative 1 to 1, or negative 1 half to 1 half. And we can multiply the entire thing by 2, and we should be golden. Do the same thing with the y, except here's the height that is relevant. And now we can say let offset x, offset, now, plus offset is it's vec2 plus x and plus y. And let's see if that works. Whoop. Oh, geez. Okay, that's silly. Thank you, compiler error. All right. So I think that's about where I'd expect that to be. Or is it here? Let's actually investigate that. Let's set the y to be 0 and see what happens. Yes, as you expect. Well, or maybe don't expect. It's actually at the bottom. So what we're going to have to do is flip this y coordinate so that 0 is at the top as you would expect. Of course, now it's not visible. It's off the screen, it seems. If we do that. Okay, so it's somewhere up here, where it's here and it's going down. If it's 0, it's up there. Or it's here, actually, but it's going up. So that's an issue with the scale. We could actually, just to demonstrate, I could do negative 1 to that. I don't know if I need to do the... There we go. Should use a different character. Let's... let's see. What's a good character? Well, a good character that has, well, you know what, at sign, that's perfect. So that's 0, 1, 2, 3, 4. 4 down. So let's see, where is my, let's do UV offset. So 4 down, that's 0 on that side, and then it's 4 divided by 16 on that side. And that should give us an at sign. Whoops. There we go. That's an at sign. Is that the right direction on the at sign? Maybe I should use something else. That is the right direction on the at sign. It's got the big snaky thing to the right. Okay, so that's good. However, the scale is a bit wonky here still. So scale x, we've got something that's going from 0 to 1. We want it to be, well, we want it to be 1 over the width of the thing, right? So is this correct? I think this might be, but I'm not 100%. Okay. All right, we scaled the y backwards. So we need to, and also this needs to be term height. There we go. That seems like a lot more than 10 down. Something's a bit off here. Maybe that is 10. What we could do here is instead of just doing a single x and y, we can do 4x in 0 to 10 and 4y in 0 to 10. We can do this. Put that in there. Still not using the character, but we'll get to that. Ah, yeah, see, so we have some extra spacing here. That's not exactly ideal. How many do we have here in the width? So If I do 20, all right. I mean, they're placed correctly. You've got 25 vertical lines. The issue is that the scale is wrong. Ah, of course. Uh, it is because it's twice. There we go. So twice divided by the width and the height, that gets us the proper scale. And now if we do term width and term height, we get what you would expect. Okay, let's see. Let's do a different character here for variation's sake. It's an ampersand. That's always fun. All right, how do we get the character code then? I counted it manually on that thing. That's not ideal, of course. So this is a U8. That's what this means. This means bytes. Uh, so what we can do is let the character X be the char, and we want to divide by, or mod 16. That gets us where it is on the row, and divide by 16 gets us that. Uh, and that means that we can do that, and then that should get us where we want to be. There we go. What we could do here as well is say that we have a term width plus x, and let the character be I as a, well, I mod 255 as a U8. That'll scroll us through them all. Why can't you? Oh, there we go. There we go. That's all of our characters. There's an upside down question mark there, but that's actually in the fonts. That is not a rendering issue. This is all our characters. The scale, of course, is not quite right. So what we could do here before we go on is to just fix the window to be a nice multiple. So width, we could do term width times, these are 8 wide, and we can upscale it by 2. And that's no height. Oh, shoot, come on. Height times, and they're 16 tall, the characters, multiplied by 2. There we go. Nice and crisp text rendering. All right. Before I finish this, did I even start recording? Yes. Before I finish this, I am going to go ahead and actually, obviously this is not a way to draw characters yet. This is not reasonable. So what I'm going to go ahead and do is make a new file here that'll actually include all of the info that we need. So, probably down there, right? Okay. What do you mean it's unused? Ooh, is that right? That was probably a mistake. Why did that work? Maybe these are the same. All right. Okay. Yeah. So I'm gonna make a struct here, and we're gonna keep track of all the characters and backgrounds and foregrounds. Foregrounds. It's gonna be a back of color. Backgrounds also a back of color, and I'm actually gonna go ahead and pull this into here. Just to have it be next to where it's going to be actually mainly used. And let's see. Let's see. We probably want this actually to be in here as well, huh? Nope, these need to be pub. And import those. So, what do we fill up our term buffer with? Well, basically, we're going to do the same thing as here, for now at least, and just generate. Well, let's actually do a clean empty one. So, characters is going to be a vec. That's 0 times term width times term height. And I need to make those U sizes. Actually, you know what? Oh. Let's do that. That's cleaner. And foregrounds is going to be, well, it's going to be black, I think. Or no, let's do white. It needs to be a back again. There we go. And then backgrounds. 0, 0, 0 times the length. G B A A B B B B B B G. Sloppy, 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 sloppy. Okay, that's our. We have a term buffer. Let's add it to this. Huh? And are you not public? No. Make all that public so that we can actually access it here. Import it there. So let's do. The reason I made it immutable is because I want to be able to. Oops. Well, what do I want to be able to do? I want to be able to put characters in places. So let's add a function for that. Self. Okay, I is, we do the math backwards. We can say that I is y times term width plus x. And then make that all a U size. We're not checking here that we're in bounds. It'll be fun when we aren't anymore. So foregrounds. There. Self.backgrounds. I is background. No, it's not. It's not private. Okay, there we go. Okay. And yeah, let's just do 10, 10, at sign, and let's make him a different color this time. Oh, and I need to write them out. There we go. Oh, oh, got there we go. All right. Next episode, I am making a constructor for color. In general, we're not going to be handling them like this. It's kind of a hassle. Okay. But yeah, so let's say we have our terminal now. Instead of I being this, it is going to be... Actually, I guess I is still dead. That's fine. However, care is... it's self-delta remove food. Oops. That's U size. X and Y are correct. I think that's... Oh no, the foreground and background. You know what? We can just do it directly here. Is it not called foregrounds? It is. Ah, but it is self. I need to probably do... There we go. That's an easier way of doing it. So, don't need that anymore. What else? What am I missing? Extra comma? There we go. We have an at sign. All right. Next step is getting this guy to move around. That's the first step to having a game. All right. See you then.